Okay, number one on the test 2 study guide, our job is to find x, y, and z. You'll notice we have 3 parallel lines cut by 2 transversals. I'm going to find x and z first because x and z both represent angular measures. And when we deal with x and z, all I care about is this one transversal and the fact that this is 80 degrees. That's the acute measure. The other measure I need to care about is the obtuse measure. So we've already established acute measure is 80 degrees. I know it's acute because it's less than 90. I know that this is a straight line, so this angle here matched up with this angle here has to add to 180, which means this angle here has to be 100 degrees, making that the obtuse measure. Once I've established the measure of both the acute and obtuse angles, then it's just a matter of establishing what kind of angles x and z are part of. You'll notice that 4x is down here, and the angle is right there, which is a little bit less than 90, so I know 4x is acute. And all acute angles are 80 degrees, so 4x has to equal 80 degrees. Dividing by 4 gets me x equals 20. If I look at angle 5z, same deal. Here's my straight line. And you can see that angle is slightly larger than a 90-degree angle, makes it obtuse. So 5z, the obtuse angle, has to add up to, or has to be 100 degrees. Dividing both sides by 5 gets me z also is equal to 20. And that's it for x and z. Now y is a completely different kind of problem inside the same problem. So we have the same picture, same parallel lines cut by the same transversals. Now this fraction 4/5 is equal to this fraction 8 over y. So 4 over 5 is equal to 8 over y. So you create a proportion, you cross multiply, this product 4y is equal to this product 40. Dividing both sides by 4 leaves me with y equals 10. You should expect on the test to have x and z part of angles. You have to figure out what x and z equal. The angles are 80 and 100, but x and z are 20 and 20. And you should expect y to be part of the segment issue. This piece over this piece equals this piece over this piece every single time. Cross multiplying, it comes out to a fraction, leave it as a fraction. This time it divided evenly, so go ahead and go that route. Example 2, the measure of angle BCD is 120 degrees. When they name an angle with 3 letters, BCD, the middle letter represents where the angle lies. The tick marks on the figure indicate that BC equals CD. So BC and CD are equal to each other. Also that AB equals BD. So this segment equals this segment. And our job is to find x and y, then p, then r and q. Okay? Very, very simple problem, and we're going to start off with the fact this is 120 degrees. You look at triangle BCD, this triangle here, 180 degrees in the triangle. So if there's 120, then 60 degrees is left over for both of these angles. So 180 degrees in the triangle. These two sides are equal, which makes these two angles equal. If they're equal and they add up to 60, I know that x plus y has to equal 60. And I know that x equals y. That tells me that x is 30 and y is 30. Once I establish their measure, I'm going to put x equals 30 right here. I'm going to put y equals 30 right here. We can quickly verify. 30 plus 120 is 180. We have a triangle that's legal. Everything's good about it. Next thing I'm going to bring to your attention is the fact that we have a straight line going on in this problem. This is a straight line right here. And if we focus on this straight line, we'll notice that p and x together make that straight line. So I know that p plus x has to be 180 because that's a straight line. X is 30 degrees. Therefore, p must equal 150. Just like that, I figured out what p equals. So the next step, we need to figure out what q and r are going to equal. And you'll notice again that these two sides are marked as equal, which means these two angles are equal to each other. Also, there's 150 degrees in this angle, which means there's exactly 30 degrees left over to make 180 in this triangle, ABD. And if there's 30 degrees left over for these angles, and Q and R have to make 30 degrees if I add them together, and I know that Q is equal to R, I can see very clearly that both of them have to be 15 degrees. And there's the rest of the problem. So 120, how much is left over from 180? Divided by 2 to figure out x and y because they're equal. X and P make a straight line. Figure out how much is left over from 180 to make P. And then however many degrees that is, subtract from 180 to figure out how much is left over from Q and R. Half of that will be the measure of those two angles. Number 3. Length of each side of the square is 12 centimeters. So they've initially started us off with 12 centimeter sides. And the circles have equal areas. That means the radii of all the circles are equal. And then what the shaded portion of the figure? Well, first of all, obviously the area of the square is going to be 12 squared, or 12 times 12. Take your pick. 144 square centimeters is the area of the square. Now, in order to find the shaded region, I have to subtract all the circles. In order to find the area of a circle, I need to find the radius of a circle. And what you need to notice about this, if I were to do this, start up here and go straight down the middle, you'll notice that this segment that's dotted should be equal to this segment here. So those are both 12 centimeters long. The other thing you need to realize is that the circles have equal areas. That means this diameter and this diameter and this diameter are equal, which means that this diameter is 4, this one's 4, and this one's 4 to make 12. 4 plus 4 plus 4 is 12. That's the diameter. And we also know the radius of a circle is half the diameter. So the radius of each of these circles is 2. And again, equal areas means equal radii. So all 9 of these circles have the exact same radius. So if I do the area of one circle, it's just pi times its radius squared. That's just 4 times pi. 4 times 3.14 is about 12.56. That's one circle. That's how big this one circle is. I've got 9 of them, so I'm going to multiply this times 9. We get 113.04 for the area of all 9 circles. So the area of the whole square is 144. The area of all 9 circles is 113.04. So the shaded area is simply the total area of the entire shape minus the unshaded pieces. So 144 minus 113.04 comes out to 30.96. Expect a similar figure on the test. The number of circles establishes how to find the diameter. So if it's 3 circles, divide the length by 3 to get how much each diameter was. If there were 4 circles, 4 by 4, let's say 16 circles altogether, divide that by 4, each diameter would be 3 and so on. It's probably going to be a similar shape to this though. So again, figure out the diameters, half the diameter is the radius, find the area of one circle, multiply by how many circles there are, subtract the circle areas from the square area to get the shaded area. Number 4, the radius of the circle is 5 centimeters. The base of the triangle is 10 centimeters. The area of the circle equals the area of the triangle. What is the height of the triangle? Now, the most important sentence in this entire paragraph is the area of the circle equals the area of the triangle. Okay? That's where we're going to get our equation from. So it says the area of the circle, that's pi r squared, equals the area of the triangle, that's 1/2 base times height. A circle area formula equals a triangle area formula. So you create an equation. That's always our first priority in solving a problem. Now if we start filling in what we know, the radius is equal to 5. So I know that number right there. The base of the triangle is 10. I know that number right there. The height of the triangle, I don't know what it is. It's h. If I fill in everything I know with what I've got written there, so I got pi times r squared, that'll be 25, equals 1/2 base, which is 10, height, which is, I don't know, we're calling it h. Just like that, pi is 3.14, 25 is a number, half is a number, 10 is a number, h is a variable. The only thing left now is one variable. If I approximate pi as 3.14 and multiply, I get 78.5. Half of 10 is 5. Just like that, 78.5 equals 5h. We simply divide both sides by 5. .7 centimeters would be the height of the triangle, approximately. It's going to be the height of the circle, or the area of the circle equals the area of the triangle. The height's going to be missing. It's just a matter of applying the area formula of the circle equal the area formula of the triangle. The missing piece is h, solve for h, and that'll be fine. Number 5, solving an equation. You'll notice we have parentheses on both sides. A distributive property is necessary to fix the parentheses. I'm going to start there. So 12 times 3 and 12 times negative 6x equals, and then 14 times 5 and 14 times negative 3x. And then there's a minus 4 just hanging out. It's not inside of parentheses, so just bring it down. Always bring down the entire equation as you go. Next step is to maybe combine like terms on both sides. The only like terms I have are right here. Everything else is unlike, so everything else stays the same. So 36 stays 36, minus 72x stays the same. 70 minus 4 is 66, and negative 42x, or minus 42x, however you want to call it. So priority 1, simplify everything as much as possible. Get rid of parentheses, combine like terms. Get yourself to this level of equation, a number and letter on one side, a number and letter on the other side at most. At this point I need letters on one side. I'm going to move the 72x over to this side. I'm going to move the 66 over to this side. Each thing I moved changed signs, so negative 72x became positive, positive 66 became negative. These signs are different, so I subtract, and it's negative because because 66 is bigger. And here opposite signs also, so I subtract, and this time it's positive because 72 is bigger. 30 equals negative, 30x equals negative 30. We always divide by this number in front of x, so I'm dividing both sides by 30. That leaves me with x equals negative 1. I can't guarantee it'll come out to a whole number or an integer on the test, but it might. So just know that that's how you do it. If at this point, just throwing a for instance at you, if we had 36 minus 72x equals 66 minus 4x, or sorry, 42x. If I had decided to go the other route, move the 42x over to the left, which makes plus 42x, move the 36 over to the right, making minus 36. Negative 72 and 42 make 30x, negative because 72 is bigger. 66 minus 36 is 30, subtracting because the signs are different, positive because 66 is bigger. I got to divide both sides by negative 30. 30 divided by 30 still equals 1, and opposite signs creates a negative answer. It doesn't matter which side you take things to, just do it correctly. Don't break any rules. Subtract when you're supposed to subtract, add when you're supposed to add, get the correct signs on your numbers, and make sure that you follow through the process properly. Number 6, solving a fraction equation. For me personally, I don't like to work with fractions and equations because I can get rid of them very easily. Before I deal with the fraction issue though, I don't want to have a mixed number. So I want to fix that mixed number. 3 times 7 is 21 plus 1 is 22. So I get 22 over 7x. Now I could put the x out in front. I'm going to put it on top because that's officially where it's at. So rather than keep it out in front of the fraction, I'm just going to throw it on top of the fraction just so there's no confusion about where it belongs. But again, the top number, multiply these, add the top. 3 times 7, 21 plus 1 is 22. Put that over the denominator 7. Again, x belongs on top. Minus 5/3 equals 31/21. That's priority 1 for me. If I'm going to get rid of fractions, I want everything to be a regular fraction. I don't want mixed numbers. Mixed numbers cause mistakes. Then I'm going to multiply the entire problem. Since it has an equal sign, this is legal. I'm going to multiply the entire problem by the least common denominator, which is 21. So times 21 is going to fix this problem into a simpler problem. The process goes like this. We multiply here. It's a division first, then a multiplication. So 21 divided by 7 is 3. 3 times 22 is 66x. Then I multiply this one. 21 divided by 3 is 7, times minus 5 is minus 35. Finally, equals this one. 21 divided by 21 is 1, times 31 is 31. Divide first, multiply the result times the top. If you get a least common denominator, it will divide evenly. If you don't, it won't. So if you try and divide it and it doesn't divide evenly, that means you didn't find a least common denominator. 21 divided by 7 is 3. 21 divided by 3 is 7. 21 divided by 21 is 1. So all three of those divide evenly. The results, 3 times 22, 7 times 5, and 1 times 31, is how you get rid of the fractions. And just like that, we got ourselves a real simple problem. Moving 35 to this side, changing its sign is going to fix it. 66x is left on the left-hand side. 31 and 35 have the same sign, so I add positive because 35 is bigger. Divide both sides by 66. We're left with x equals 1. Again, I'm dividing by the number in front of x. It just so happens it's the same number on both sides. Always divide by what's in front of the letter when you divide. Number 7, kind of a mixture of number 5 along with some powers. So in fact, just one power here. So I got a distributive property issue going on here. I got a power situation. I got a minus situation there. So I want to fix all that stuff first. All right. So negative 4, which is what's actually being multiplied, negative 4 times 3x is negative 12x. And negative 4 and negative 2 make positive 8. So negative 12x plus 8 is the result. There's 2 objects in here. You should get 2 objects after you multiply. 3 squared is 9. The minus sign happens after the square. So the 3 is being squared, not the minus sign. It stays minus 9. Minus 15 is just kind of hanging out, not doing anything, so it's going to stay minus 15. Equals is still equals. Then I got a minus x doing the same thing as minus 15, nothing. And then minus 6 means plus 6. So 2 minuses means plus. Okay, 1 minus means minus. Powers only affect one object, so 3 is being squared. The minus sign isn't, stays minus 9. Just be cautious in that process there that you do everything correctly. There's a lot of different rules going on. Distributive property, raising a number to a power, 2 negatives make a positive, so minus becomes plus. Doesn't become times positive, but it becomes plus 6. Next thing I would do is I would add like terms together, so all 3 of these guys are like terms. So negative 12x stays as is. 8 minus 9 is negative 1, minus 15 is negative 16. So that's where I'm going to be at this point. What I would do at this point, I'm at the same point I was in number 5. Now I've got letters on both sides, numbers on both sides. I'll move the 12x to the right, becomes positive 12x. I'll move 6 to the left, becomes negative 6. Be careful that there is a 1 in front of that x. Don't forget about that 1. 12 minus 1 is 11. Opposite sign, subtract. 12 is bigger, so it's positive. Negative 16, negative 6, those are the same sign, so I add negative because 16 is bigger. So just because you see minus doesn't mean subtract. Just because you see plus doesn't mean add. Opposite sign subtracted, same signs added. Divide both sides by the number in front of x, which is this number, 11. So x equals negative 2. Okay, all 3 of those came out to integer answers. Probably come out the same way on the test. But if they come out as fractions, just maybe check your work. If you did everything right, that's all right too. Number 8, same as number 6, we got a fraction problem. This time we don't have any mixed numbers, so we can go immediately to the least common denominator. Least common denominator of 5, 7, and 35 is 35. Once again, just to make sure everybody understands, I'm going to multiply. The multiplication process is divide first, then multiply result. So 35 divided by 5 is 7, times negative 2x is negative 14x. 35 divided by 7 is 5, times positive 4 is positive 20. 35 divided by 35 is positive 1, times negative 22 makes negative 22. So priority 1, get the fractions gone. Once you get the fractions gone, solve the equation. I'm going to move the 20 over to the right. Positive 20 moves across, becomes negative 20. Negative 14x stays as is. These numbers have the same sign, so I add them together. 22 is bigger, so it's negative. Divide both sides by negative 14. 2 negatives make a positive. 42 divided by 14 is 3. So that's actually a little simpler than number 6 because you have the mixed number, but after that it's the same difficulty. Number 9, expand. This means to use the distributive property to make this expression as simple as possible. The first priority in a problem of this variety is to make each object as simple as possible. So I have object 1, I have object 2, and I have object 3. And simple to me means that there's no negative powers and all the letters have exactly one of each type. So looking at this outside piece, there's one A, there's one Y, there's one P. That's all good except the Y is to a negative power. So I make my fraction bar. A is right where it belongs since it's to the first power. P is right where it belongs because it's to the first power. Y belongs on the bottom because it's on top with a negative power. So you move it down where it belongs. The second term. 3 is fine. Y to the fourth is to a positive power. A is to a positive power. P is to a negative power on the bottom. It belongs on top. P to the first, which I don't have to put a 1 on there. It's understood to be first power. Then I got a minus sign. And then I got 2AP over Y to the fourth. 2 is behaving itself. A and P are both behaving themselves. They're all to positive powers. Y is to the negative fourth. On the bottom, it belongs on top. I'd probably put it over 1 just to be safe. So I create the same exact expression. Positive power, positive power, positive power, 1 of each letter. 1 of each letter, positive, positive, positive power. 1 of each letter, positive, positive, positive power. Once I do that, now it's just a multiplication. When you multiply fractions, top times top, bottom times bottom, don't try and reduce them this step. So, numbers go out in front, A, P, and Y, so A, P, Y to the fourth. Those are the different letters. On the bottom, the same 3 letters, A, P, and same powers even. So, I like alphabetical order. I think things line up better. It's a lot easier to see what needs to be done next. But A times P times Y to the fourth is just AP times Y to the fourth. There's no way to multiply them together other than just stick them together. When I do the second multiplication, this one here, I've got minus because I have opposite signs. Again, the number's 2. Numbers always go out in front. I've got A times A makes A squared. And then I've got PY to the fourth. On the bottom I have PY to the fourth times 1, which is just PY to the fourth. After I distribute, I'm now back to a point like I was in the very first step. I want 1 of each letter, all powers positive. Well, the powers are all positive, that's good. But I've got too many A's, too many P's, too many Y's. These are exactly the same, exactly the same, exactly the same. They all cancel. The 3 didn't cancel, so it stays 3. If there weren't a 3 there, you'd have to put a 1 there. All right, be careful of that. On the second one, 2 is behaving itself. A squared is behaving itself. Too many P's, they cancel. Too many Y's, they cancel. If they happen to be different powers, then just subtract the powers, but the answer where the bigger power is. In this case, they're exactly the same, so they just cancel. 3 minus 2a squared is the simplest expression possible for that problem. Number 10, simplify. All right, this is getting into our exponent rules. Our first priority on an exponent problem is to deal with this picture. A power raised to a power. Even if there's negative powers, 0 powers, worry about that in the next step. Those 2 things I have highlighted in blue, they have to be dealt with first. And one other thing to remember before we start dealing with that is that everything in there has a power on it. So 3, even though it's 3 to the first power. We have y to the second, x to the negative first. Those, of course, have powers listed. So when I take these 2 blue things, I'll do those in blue. What happens is the bases, 3, y, and x, stay exactly what they were. You multiply the inside times the outside power for each base. So 1 times negative 2 makes negative 2 on the 3. 2 times negative 2 makes negative 4 on the y. Negative 1 times negative 2 makes positive 2 on the x. On the bottom, x is the base. 3 times 0 is 0. All right? Again, we'll deal with 0 and negative powers in the next step. Don't worry about it here. Just do what you're supposed to do. Power times power, keep the base the same. Everything else in the problem at this point, y squared, x to the first, y to the negative third, and x to the third all stay exactly where they were. Nothing happened to them because I'm not dealing with them yet. Only the stuff in blue changed. The stuff in black is as it was. I did put a first power on this, so I put that in there, but other than that, I didn't mess with those. Next step. Now I'm going to deal with my negative powers and my 0 powers. So I have to deal with this guy, and this guy, and this guy, and this guy. Everything circled in green has to be dealt with. I'll deal with those things in green. Everything else, I'm going to just leave black. I'm going to change that to black. So 3 to the minus second on top means 3 squared belongs on the bottom. Y to the negative fourth on top means y to the fourth belongs on the bottom. X to the 0 power equals 1 times other stuff doesn't matter. Y to the third power belongs on top to account for the y to the negative third power. Everything else here, x squared, y squared, and x on top, stay x squared, y squared, and x to the first on top. X cubed stays on the bottom. Deal with all the negative powers, put everything where they belong. That's step 2. Step 3, I want to have only 1 type of each letter on top, only 1 type of each letter on the bottom. That's also the place I'm going to take care of any numbers to power. So 3 squared equals something. I got too many y's. I got too many x's on top. On the bottom I got 1 x and 1 y. The bottom's perfect like that. So all the stuff in purple is going to change to new stuff. I'm going to uncircle because I can't see some of those powers now. So all the stuff on top has to be fixed and what's on the bottom. So x squared and x to the first makes x to the third. We add the powers. Y cubed and y squared makes y to the fifth. Again, adding the powers. 3 squared equals 9. 3 times 3 is 9. And then y to the fourth and x squared, or x cubed, sorry, stay the same. And final step is division. And you'll notice division, we have too many x's on top, or I should say too many x's in the problem. Too many, 2, and too many y's, there's 2 of them. So 9 is staying right where it's at. Always put numbers out in front. X cubed over x cubed are exactly the same, they cancel. There's bigger number of y's on top than the bottom, so y belongs on top. 5 minus 4 is 1. Y over 9 is the simplest expression out of that problem. That used every process in that. So we had the power to the power issue, we dealt with it. We have the negative and zero power issues, we dealt with it. We have too many x's and y's on top. We have a power expression on the bottom, we dealt with it. We have too many x's in the problem, too many y's in the problem. We dealt with it by dividing, subtracting powers, putting the answer where the bigger power is. And if the powers match exactly, just throw them out. Number 11, same idea, same issues going on. So I'm going to do this a little bit more quickly. Once again, I'm going to deal with those guys first. If I do that, I've got my fraction bar. I've got x and y and 4 and x and x. Those are the bases out of both of those parentheses issues. Negative 3 times negative 2 is positive 6. 1 times negative 2 is negative 2. 1 times negative 2 is negative 2. And 1 times negative 2 is negative 2. Negative 7 times 0 is 0. Every power multiplies from the inside to the outside on the basis. The bases x, y, 4x don't change. X doesn't change. Only the powers change. Everything else stays as is. Y to the 6th, x squared, x to the first, y cubed. Again, I put a first power just to be safe. Next, I'm going to deal with my negative or zero powers. All three of these guys are negative powers. That's a zero power. That doesn't matter. The rest of them are going to move. So, I'm bringing 4 squared down. Notice I put that in front. I like my numbers in front. I'm going to bring in a y squared and an x squared down. Everything else stays right where it's at. So I still have an x to the 6th on top, a y to the 6th on top. I got an x squared, x to the first, and y cubed on the bottom. Next part of the process, 1x on top, 1y on top. The top is perfect. The bottom, I've got a power I got to evaluate. I got too many y's, I've got too many x's. So I'm going to multiply the x's and y's and evaluate the numerical expression on the bottom. So 4 squared is 16. 2 plus 2 plus 1 is 5, total for x. 2 plus 3 is 5, also total for y. Notice the top doesn't change. It stays x to the 6th, y to the 6th. And then at this point I've got 2 x's and 2 y's, one on top and bottom. X belongs on top because 6 is bigger than 5. 6 minus 5 is 1. Y belongs on top because 6 is bigger than 5. 6 minus 5 is 1. 16 belongs on the bottom because there's no other numbers affecting it whatsoever. X, y over 16 is the least simplified answer for that problem. Number 12, simplify by adding like terms. Simplify by adding like terms. First off, you want to simplify each term. So I don't want to even worry about the whole problem until I deal with this guy all by itself and this guy all by itself. And I'm looking for the same things I did with the expand problem. I want one of each letter, I want all powers positive. So there's too many x's, too many y's. There's negative powers and too many y's. So those are the types of issues we need to fix, and we need to fix them the same way we just did the last two problems, by the power rules. And since there's so much going on in this, I might do it in a couple steps. So this one here, I'd probably go 3x cubed y squared over x squared y squared. X squared times x to the first makes x third. Y squared is behaving itself on top. 3 is behaving itself on top. X squared behaving itself on the bottom. Y times y is y squared. These cancel. X cubed over x squared makes x to the first attached to the 3. So this term here, simplest form, is 3x. The second term, I got some negative powers first. I might move the y to the first up, the x to the first up, and the y squared down, kind of there. And then deal with the too many y's situation. So I got plus 2. I've got an x on top, which is behaving itself. I've got y, which is y squared on top. And I've got a y squared on bottom. Y squareds cancel, leaving me with plus 2x. Simplify each term as much as possible. Now I have one of each letter, specifically x. Y disappeared because of cancellation. And the x's are exactly the same letters to exactly the same powers in the exact locations numerator. So these are like terms. We add like terms by adding the coefficients. 3 plus 2 is 5. X. X to the first is what made them the same. X to the first is what you get on your answer. You do not change powers when you're adding letters. Number 13, evaluate. Now, these evaluation problems, my personal preference is this. I want to simplify this first. I want to do the distributive property to expand it to make it as simple as I possibly can before I start throwing numbers in it. So if we consider that, this right here is just xy, because x to the 0 equals 1. That's being multiplied by xy minus x squared. The second thing I notice, xy times xy makes x squared y squared. And xy times x squared makes minus x cubed y. So just basic distributive property stuff, I've changed the expression which it was into a simpler, more concise expression. Now, what I'm looking at is x squareds, y squareds, x cubes, and a y. So for me personally, I would probably figure out what that equals. I'd figure out what that equals. And I'd figure out what that equals. And I'd figure out what that equals. And I just put those numbers in. So if I'm looking up here, I can see very clearly that x equals negative 1. That means x squared is equal to positive 1. X times itself. Negative 1 times negative 1 is positive 1. I also know that x cubed just means to multiply another negative 1. That also equals negative 1. Looking over here at y. Y is equal to negative 5, which means y squared is equal to positive 25. Negative 5 times negative 5 is positive 25. So x squared is a positive number because you're multiplying a number by itself, negative or positive. Y squared, same deal. At this point, I know what everything equals. So if I just come down here and start substituting in, x squared is 1. That's being multiplied by y squared, which is 25. That's being subtracted by x cubed, which equals negative 1, being multiplied by y, which is negative 5. Okay, so instead of having to stick stuff in there and multiply some stuff and then distribute and all that stuff, I've already got my answer simplified here, so I just have to figure out each of these 4 things. Then I'm just left with a product here and a product here. 1 times 25 is 25, 1 times 5 is 5, and 1, 2, 3 minuses makes a minus. 25 minus 5 is equal to 20. To me, that's the easiest way to evaluate. Simplify the expression, substitute in each piece, deal with power structures as just powering the letters. So x squared and y squared and x cubed, what do they equal? Substitute them in, then you just have to multiply and add or subtract. Number 14, simplify. We got braces and brackets and parentheses. Always keep working your way inward till you find the innermost parentheses. So this parentheses is inside the entire bracket, so is this. So these guys have to be evaluated first, then the bracket, then the braces, then the times 3. So negative 3 is staying here, followed by a brace, followed by a 2 bracket. I'm not even messing with that stuff yet. Right here, 3 squared is equal to 9. The minus sign is not being squared, so I get negative 5 minus 9. Minus. Negative 16 plus 3 is negative 13. That's step 1. Figure out the power. This parentheses has nothing to do with that one, so I can work that out. Opposite signs, they're just regular numbers. Opposite signs, a negative number is bigger, so it's negative. Okay? Minus 5 and minus 9 have the same sign, so I add, and 9 is bigger, so it's negative. So I got minus 3, brace, 2, bracket. I got negative 14 plus 13 in the brackets. Negative 14 plus 13 is negative 1. Then I got a plus 1 inside the brace. So I've dealt with both parentheses, and I dealt with what's inside the bracket down to a single number. At this point, still inside the braces, this is multiplication, that's addition. Multiplication's first, negative 3 brace. 2 times negative 1 is negative 2 plus 1. Negative 2 plus 1 is negative 1. Opposite sign, subtract 2 is bigger, so it's negative. And finally, I have the multiplication by negative 3. Negative 3 times negative 1 is equal to positive 3. The problem on the test should be structured similarly. It's just a matter of working your way through it carefully. Don't leave anything out as you're going. Don't start changing subtractions or additions into multiplications. You should be good to go. Number 15, another simplified problem. Once again, powers affect a single object. So 9 to the 0 power, not the minus sign. 8 to the 0 power, not the minus sign. So if I'm doing that, 9 to the 0 power is equal to 1, the minus sign happens after the power. Minus parentheses, I got negative 5 minus 3 minus 1. 8 to the 0 equals 1, the minus sign happens afterwards. That's being multiplied by negative 2. Minus negative 13 minus 14 plus negative 5. So I haven't even dealt with any of that stuff. I just dealt with the powers first. Next thing I would do. This right here is negative 9. They're all the same signs. You add 5 plus 3 plus 1 is 9. They're all negative, so it's negative. Negative 1's here. This is multiplication. Negative, negative, negative makes minus. 9 times 2 is 18. Minus 13 minus 14 is minus 27. Again, same sign to add. Minus minus means plus. And then I got plus minus 5, which means minus. Change everything to a plus or a minus, depending on the signs. 1, 2, 3 minuses makes a negative. 1 minus makes a negative. 2 minuses makes a plus. 1 minus makes a negative. These are all negative. That one's positive, so 27 is my positive result. 1 and 18 and 5 make 24, so minus 24 is the negative result. 27 minus 24 is 3. Historically, this test has not been great for Algebra 2 students. The main problem has been not paying close enough attention to detail. You need to pay attention to detail. Look at what it's asking you to do. When signs are involved, make sure you apply the proper sign rules. If it's an addition or subtraction, your sign is determined by the bigger number. If it's multiplication or division, your sign is determined by an odd number of negatives makes a negative, an even number of negatives makes a positive. Powers, a lot of times people want to put plus 1 instead of minus 1. They don't think about what the power means. So pay close attention to detail in each step. That is the key to doing well on this test.